here we go. We have, I think you can actually hear me through the speakers now, can't you? So I should probably, that's what I continue to tell myself. Okay, so as we begin the investigation of solving right triangles, I want you to understand that in each class so far, I've definitely identified students who did not completely understand that SOHCAHTOA idea the first time they saw it. And namely, this was the issue. Do I label a side as opposite or adjacent? How do I tell? And how do I know whether or not I choose sine or cosine or tangent? So I want to let you know that it's okay that you're in that situation right now, that we will figure that out together. So how does it work? Right triangle trigonometry says we have to have a right angle. Once we know the right angle, we always know the hypotenuse. It's across from the right angle. We then have two other angles that are of interest to us. One is this angle right here. We'll call it theta. As I draw the angle, watch what happens. I cross over the hypotenuse and I cross over this side. That's how it gets its name, adjacent. Adjacent means next to the angle. Do you see that? So if you're ever wondering, do I label it opposite or adjacent, draw the angle and see which side comes up. The side that is not part of the angle is what's across from the angle. It is the opposite. Notice if I were to change this, if I were to refer to this as beta, say a different angle, all of a sudden, is this the opposite side or is this the adjacent side any longer? No, now this is the opposite side and this is the adjacent side. So it depends on the angle that you are speaking of. We good? So this is the acronym that I never learned, but I use as I teach because it seems that people get it. I always thought of it in terms of y over r and x over r and things of that nature. That's how I always thought of it. So sine of theta, you can see, is opposite over hypotenuse, or as I thought of it, y over r. When we do right triangle trigonometry, we don't need to really concern ourselves with cosecant. You know it's just a reciprocal anyway. Cosine is the adjacent divided by the hypotenuse, or x over r. And tangent is the opposite over the adjacent, which is y over x. So let's start by identifying not all 6, but we will just focus on 3. Nope, I can't. Too late. Well, thank you for granting me permission. Can I start teaching now? Whoa, look it out. Thank you. All right. Find the exact value of the 3. So we're going to do sine of theta, cosine of theta, and tangent of theta, given this triangle. What side is 13? Opposite, adjacent, or hypotenuse? Very good. It is the hypotenuse. Emma, do you see why? Or are you just saying that? Which side is 5? It is the opposite. So the missing side is the adjacent side. Because as I draw the angle theta, you can see that the adjacent side is part of the angle. Now, does anybody know what the missing side is? 12. Ishika, how did you know 12 so quickly? You did the Pythagorean Theorem. I would encourage you guys to please remember this, okay? I found that many students don't remember it. Start to convert these to memory. 3, 4, 5 is a right triangle. It satisfies the Pythagorean Theorem. There are an infinite number of possibilities of numbers that satisfy Pythagorean theorem. Some of them we remember better than others. It works out that if you do any multiple of 3, 4, 5, such as 6, 8, 10, that works as well. Or if you were to do, say, 0.3 and 0.4 and 0.5, that would work as well. Now, other than 3, 4, 5, we also have, as Ishika said, 5, 12, 13. Now, you could do the Pythagorean theorem to come up with that, or you could just remember it's a special right triangle. Anybody remember any others other than 3, 4, 5, and 5, 12, 13? Very good. 8, 15, 17. 7, 24, and 25. And we'll pause with those, but those are the most common ones that people come up with. So, what is sine of theta? 5/13. What is cosine of theta? 12/13. Carissa is on a roll. Tangent of theta? 5/12. We all good? Okay, look at the next one. These are not Pythagorean triples. We have a right angle, and if you notice, theta is located up in the corner. Might be a little bit more difficult to see. I will draw the angle of theta so that we can identify the sides appropriately. What side is 2? Adjacent, what side is 4? Opposite, what side are we missing? How will we determine the hypotenuse? The Pythagorean theorem, 2 squared is 4, 4 squared is 16, that's equal to c squared, or 20 is equal to c squared. Yep, 2 roots of 5, very good. So I have sine of theta, cosine of theta, and tangent of theta. Sine of theta is what? Yeah, 4 over 2 roots of 5. Now, if you notice, the 4 divided by the 2 cancels, giving me 2. And so you have 2 over the root of 5, which is 2 roots of 5 over 5. As I do cosine, I get 2 over 2 roots of 5. The 2's go away, and I get the root of 5 over 5. What about tangent? Sine over cosine, or just opposite over adjacent. So I've got dos, which is Spanish for 2. Are you ready now to start solving for missing sides of a triangle? Yes. Here's where we put it all together. We have a right angle in a triangle. We have an angle of 42 degrees. Trigonometry allows us to solve for angles. Angles or sides given only one side. So we have 9 and we have x, this missing side. What side is 9? Opposite, adjacent, or hypotenuse? How about x? So will you choose to use the sine, cosine, or tangent? Sine. The sine of 42 degrees is equal to 9 over x or x over 9? 9 over x. I'm going to cross multiply. I get 9 is equal to x sine of 42. Divide by the sine of 42. 9 over the sine of 42 is equal to x. I take out my handy-dandy calculator because I have not memorized the sine of 42 degrees. I go to mode, and I make sure that my calculator is in degrees. If it's in radians, you'll get the incorrect answer. I go 9 divided by the sine of 42, and I compute 13.45. Does it make sense that that side is longer than 9? Why? Because it's the hypotenuse. So we assess the reasonableness of our solution. Please, on your own, try the next two. Ready, set, go. We check the answer? Okay, So here you would choose to use cosine of 63 is equal to x over 14. You solve and you get x is. Here you choose to use tangent of 27 degrees is equal to x over 9.4. You get x is. Okay, so we need to go over it. And what does this end up to be? Noah? You're okay? Are you sure? So you just selected the wrong trig function. You see why you do cosine? Oh, no, that's okay. That's totally normal. That's legit. Like, I get that. Emma? Okay, okay, so you guys, you're all brilliant. Excellent. Like, these are the mistakes that happen. People do 14 over x to x over 14. People's calculators are in radians instead of degrees. These are all important issues. So we got it. We're all good, though? Okay. I'm going to give you your assignment that we're going to go through. Okay, here we go. You are going to do the odd problems, the problems on the left-hand side, and they're going to kind of set up like this. First of all, you're given a right triangle, and for the purpose of solving right triangles, we're going to say if there is a right angle, we will always call it angle C. Very good with that? I don't care which one you call it, A or B, but if you look at the problem, it says B is 32. That's going to be smaller than the other one, so I'll put B over there and A up there. If you switch it up, it doesn't matter. Just make sure that C is 90. So I put 90 there, and I put 32 for B. Now, the large or the capital letters are angles. The lowercase letters are sides. How do we know which side? Side C is opposite angle C. Side A is opposite angle A. Side B is opposite angle B. Am I clear? All right. So I know that side C is 8. One of these three that we have yet to find, angle A, side A, and side B, one of these is super easy to figure out. Which one? Side A? Angle A. Why is angle A easy to figure out? All angles in a triangle add to 180, so you get 58 degrees. Great. Now I need two more. You have two angles. Would you like to use the 58-degree angle or the 32-degree angle? We'll use the 32-degree angle. So, would you like to find side A or side B? It's up to you. Okay, Willie wants to find side A. Is side A the opposite, the adjacent, or the hypotenuse? The adjacent. Is side C the opposite, the adjacent, or hypotenuse? Hypotenuse. So, there we go. Are we going to choose to use sine, cosine, or tangent then? Cosine of 32 degrees is equal to the adjacent, which is A, divided by 8. I cross multiply. I get A is equal to 8 cosine of 32. I've not memorized the cosine of 32. I need my calculator. I make sure I'm working in degrees. I do 8 cosine 32. Enter. Boom. 6.78. Uh-oh. I now need to find side B. Is side B the opposite, adjacent, or hypotenuse? Opposite. So I could use opposite and hypotenuse. So what would I use for that? Sine. Sine of 32 degrees is equal to B divided by 8. Cross multiply. B is 8 sine of 32 degrees. I get 4.24. I didn't have to use sine or cosine or tangent in order to figure that out. What could I have done instead? The Pythagorean Theorem. You have now solved the triangle, and I'm going to show you how to check the reasonableness of your solutions. Largest angle, largest side. Smallest angle, smallest side. Middle angle, middle side. Great way to check the reasonableness of your solutions. Doesn't tell you for sure that they're right, but it does tell you if they're reasonable. Today, you will work on the left-hand side, not the right-hand side. Tomorrow, we'll do the right-hand side. Are you good? Go team!